Lesson 2, Project Help Video. Muggle Joseph thinks that the product of 15 plus 2i times 4 minus 7i gives a real number, which is written as 30 plus 0i using the form a plus bi. Is he correct? If not, what is the correct answer? So let's go ahead and let's multiply this out here and see if we end up with 30 plus 0i. So I'm going to take my 15 plus 2i times 4 minus 7i, and I'm going to FOIL. So I'm going to do my first term. So 15 times 4 gives me 60. 15 times a negative 7i gives me a negative 105i. Now my inner terms, 2i times 4 gives me a plus 8i. And my last terms, 2i times a negative 7i gives me a negative 14. 7 times 2 is 14. I times I gives me an I squared. So now I'm going to combine like terms. So I have a negative 105i and a positive 8i. So I'm going to have my 60 still. Negative 105i plus 8i gives me a negative 97i minus, and I still have my 14i squared. So now I got to remember that I squared equals negative 1. So I'm going to go ahead and plug that into my formula here. So I'm going to keep my 60 minus 97i minus 14. Instead of I squared, it's times negative 1 because I squared equals negative 1. So now I still have 60 minus 97i. Negative 14 times a negative 1 gives me a positive 14 because negative times negative is a positive. Combine like terms, positive 14 and 60. 60 plus 14 gives me a 74 minus my 97i. No more like terms, so that's my answer. Now that does not match the 30 plus 0i that Muggle Joseph thought that it was. So, is he correct? No, he is not correct. And then our second question asks, if he's not correct, what should the answer be? Well, the answer should be 74 minus 97i. So that is what we end up with, that no, he isn't correct, and it should be 74 minus 97i. Muggle Joseph showed the 10 plus 3i times 4 minus 2i minus 10 plus I times 4 minus 2i is equal to 8 plus 16i as shown in the table with his justifications. Is her proof correct? If not, where did she make a mistake? So it should be, is his proof correct? And if not, where did he make a mistake? So let's take a look. So we start out with the given, which is the 10 plus 3i times 4 minus 2i minus 10 plus I, 4 minus 2i. Then her reason for step 2 is she factors out 4 minus 2i. So let's see if she factors that out properly. So if she factors it out properly, we should still have our 10 plus 3i, which we have, minus the quantity 10 plus I in parentheses. Well, she put the minus, but then she didn't put the 10 plus I. He didn't put the 10 plus I in parentheses. So because he didn't do that, he's now changing his problem. Because now he's saying if we were to distribute this negative, if we have a negative and then 10 plus I, and we were to distribute that negative inside to both of our parts, we would end up with that being the same as negative 10 minus I. But we have negative 10 plus I, which is not the same. So that's where the mistake was made. It should have been a negative 10 minus I here in order to properly factor it out. So, is the proof correct? No. Where did they make their mistake? They made their mistake in step 2 by not properly distributing that negative sign. Muggle Joseph says that the product of 8 over 5x plus 10 over 3i and 8 over 5x minus 10 over 3i is 64 over 25x squared plus 100 over 9. Is his product correct? Well, let's go ahead and do the multiplication. So we have 8 over 5 times x plus 10 over 3 times I times 8 over 5x minus 10 over 3i. So I'm going to go ahead and FOIL. First term times first term, 8/5 times 8/5, multiply tops, 8 times 8 gives us a 64. On the denominator, 5 times 5 gives us a 25. X times x is an x squared. Outer terms, 8/5 times negative 10/3, so we get a negative 8 times 10 gives me 80 on top. 5 times 3 gives me a 15, and then I have my x and my I. My inner terms here, 10/3 times 8/5, 10 times 8, 80, 5 times 3, 15, and then I have an x and an I again. And then my last terms, the 10/3 I times the negative 10/3 I gives me a negative 10 times 10 is 100. 3 times 3 is 9, I times I is an I squared. Go ahead, combine like terms. So we have this xi, negative 85th xi plus 85th xi. Well, since they have the same number in front, they cancel each other out. So we're left with just the 64 over 25 x squared minus 100 over 9 I squared. Remember that I squared equals a negative 1. So we now have 64 divided by 25 x squared minus 100 divided by 9. Instead of I squared, I'm going to substitute in that it equals negative 1. So now I have 64 over 25 x squared, negative 100 over 9 times a negative 1 gives me a positive 100 over 9. So that's my final answer. Now I need to see, does it match up with the final answer that Muggle Joseph got? Well, yes, it does match up. It's the same. So is his product correct? Yes. His product is correct because we got the same answer. Muggle Joseph claims that the equation 5x minus 6i times 4x minus 9 times 5x plus 6i equals 0 has 3 roots, a real root and a complex root with a multiplicity of 2. Is he correct in his claim? Well, let's go ahead and let's figure out what the roots are. Remember that when you have an equation in the form here where it's equal to 0 and it's completely factored out, we're going to take each of the factors, set it equal to 0, and solve. So I'm going to start with my 5x minus 6i equals 0, and I'm going to solve for x. So I need to add 6i to both sides. So I now have 5x equals 6i. Now I need x by itself. 5 is multiplied. Undo multiplication by division. Divide on both sides. So I now get x equals 6 over 5i. So that's one root. Let's go to the next one. I got 4x minus 9 equal to 0. Add 9 to both sides. 4x equals 9. Now we have 4 times x. I want x by itself. Divide by 4. X equals 9 divided by 4. It's the second root. And our last one here, 5x plus 6i equals 0. Minus 6i minus 6i. 5x equals a negative 6i. 5 times x, we want to get rid of the 5, so we're going to divide by 5. X equals negative 6i divided by 5. So he is correct in that there is 3 roots. There is one real root. Our 9/4 is our one real root. And we have 2 imaginary roots because we have I in both of the other. Now, but he says that the complex root has a multiplicity of 2. If that's true, that means our other 2 roots would be the exact same. But they aren't the exact same because we have a positive 6/5 I and we have a negative 6/5 I. So it's not a multiplicity of 2 because they're not the same. So, is he correct in his claim? No, he is not correct in his claim because it does not have a multiplicity of 2. Hope this helps with your lesson 2 project.